A measure of location is a single value which describes a position in a data set. If the single value describes the center of the data, it is called a measure of central tendency. First, let's take a look at how to work out the mean, median, and mode of a set of ungrouped data and from ungrouped frequency table. Now, let's take a look at this example. Peter collected wild mushrooms every day for a week. When he got home each day, he weighed them to the nearest 100 grams. The weights are shown below. Mode. The mode or modal class is the value or class that occurs most often. As you can see from these weights, the value that occurs most often is 700 grams. So the mode for these data is 700 grams. Median. The median is the middle value when the data values are put in order. So first I'll arrange the weights shown below from the smallest to the largest. As the value in the middle is 700 grams, the median for this data is 700 grams. Mean. The mean is the sum of all the observations divided by the total number of observations. The mean can be calculated using the formula shown below. X bar equals the sum of data values divided by the number of data values. Here, the X bar represents the mean of the data and this means the sum of the data values and N is the number of data values. So, to find the mean for these data, add all the weights together and then divide by the number of weights shown here. So, its mean equals 500 plus 700 plus 400 plus 300 plus 900 plus 700 plus 700 divided by 7 equals 4200 divided by 7 equals 600 grams. Combining means. If set A of size N1 has mean X1 bar and set B of size N2 has a mean of X2 bar, then the mean of the combined set of A and B is X bar equals N1 times X1 bar plus N2 times X2 bar divided by N1 plus N2. For example, on a science test, the mean mark for a group of 8 students is 65. The mean mark for a second group of 12 students is 72. Calculate the mean mark for the combined group of 20 students. So, X bar equals 8 times 65 plus 12 times 72 divided by 8 plus 12 equals 520 plus 864 divided by 20 equals 69.2. So, the mean mark for the combined group of 20 students is 69.2. As you can see here, the sum of data values equals mean times number of data values. So, the sum of data values for the first group is 8 times 65 equals 520 and the sum of data values for the second group is 12 times 72 equals 864. So, to find the mean mark for the combined group of 20 students, we add the sum of data values of the two groups and then divide it by the total number of students in the two groups. For data given in a frequency table, the mean can be calculated using the formula shown below. X bar equals the sum of the products of the data values and the frequencies divided by the sum of the frequencies. Example, the table below shows the shirt collar size X been recorded of the male students in his year. The mode for this data is 16.5 as a total of 34 male students wear a shirt collar size of 16.5. 16.5 is the collar size with the highest frequency. The median. First add the frequencies to find the number of observations. So it's 3 plus 17 plus 29 plus 34 plus 12 equals 95. There are 95 observations. The median is the middle value, so the median is 95 plus 1 divided by 2 equals the 48th observation. Since 95 is an odd number, we added 1 before dividing by 2. There are 20 observations up to 15.5 and 49 observations up to 16. So the median is 16. The mean. To find the mean, multiply all the data values and their frequencies and add them together, then divide by the sum of the frequencies. So, X bar equals 15 times 3 plus 15.5 times 17 plus 16 times 29 plus 16.5 times 34 plus 17 times 12 divided by 95 equals 1537.5 divided by 95 equals 16.2. There are times when you need to decide on the best measure to use in particular situations. Mode. The mode is used when data are qualitative or when quantitative with either single mode or two modes by model. There is no mode if each value occurs just once. The median is used for quantitative data. It is usually used when there are extreme values as they do not affect it as much as they affect the mean. This is used for quantitative data and uses all the pieces of data. It therefore gives a true measure of the data, however it is affected by extreme values. Now, take a look at our previous example. If you were asked as to what a shirt manufacturer might use when planning production numbers among the mean, median and mode, you need to decide on the best measure. A shirt manufacturer planning production numbers will aim for the most common collar size. So, a shirt manufacturer might use the mode, as the mode is an actual data value and gives the manufacturer information on the most common shirt collar size worn. Here, the mean and median cannot be used as the mean is not one of the data values and the median does not indicate the most popular collar size.